So now in this series, we are going to introduce a concept called the moment. And this is not Kodak moment. This is moment in the realm of vector statics and in just the study of mechanics. Now, before I actually get into what a moment is and some of the more technical definitions of what a moment is, I'm not going to cover that definition specifically in this video because there is some prerequisites, some material that we need to review and understand before we get to the concept of a moment, and that is vector products, also known as cross products. So in this video, it should be more or less a review from like linear algebra, what a vector product is, how to compute one, and then we'll also do a quick little example, a numerical example, to kind of solidify the information in this video. But very quickly, if you want a really kind of crude definition of what a moment is, imagine that here in this plane, so imagine you're just looking down into this video. So you're looking down into this plane, and there is some sort of a lever here. So this lever, oops, that should be drawn a little bit higher. It should be at the center of this pillar. So you can think of this right here as some sort of a column that's coming in and out of the page, and attached to that column is this lever. Now, this lever causes the column to rotate. So imagine you come up to this lever, and at the end of it, you apply a force, a perpendicular force here, and that's very important. This has to be perpendicular to this lever here, this lever arm, and you start pushing on this lever. Now, what's going to happen is that this lever is going to start to move, and it's also going to cause this column to rotate about its axis, which is right here. And again, this is coming in and out of the plane, so you're looking at this from the top. Now, what we say in statics, very crudely, is that this force right here, this perpendicular force, is causing something known as a moment about this axis right here. So you can imagine this lever right here, as it rotates this way, it's causing some sort of a rotational force, if you will, about this axis. So that's kind of where I want to stop there. Obviously, we'll get into what the real definition of a moment is in a few videos, but that's just kind of a crude example to kind of give you some sort of sense of what we're going to be covering in the next couple of videos. Okay, so back to this video. In this video, we're going to cover vector products very, very quickly. You should already know what a vector product is, but in case you don't, this is a good video to kind of understand that concept, because we are going to use this very immensely to understand what a moment is and for the entirety of statics and beyond. So a vector product, or also known as a cross product. Let's say you have a two-dimensional plane here. So I'll draw this two-dimensional plane here. It's going to be quite large, but you kind of get the picture. So this is a 2D plane, and within this plane, we have two different forces. Let's say one force is here, and then the other force is somewhere over here. And I'm going to call this force right here vector P, or force P, and this one down here vector Q. So again, these two forces are within this plane right here, so they are coplanar forces. Now, when we say we need to take the vector product of these two forces, what I really mean is that we need to do something called cross multiplication between vectors. So when I say, hey, take the cross product or the vector product of these two forces, what I'm really saying is, what is Q cross P? Now, this right here, the sign, you might say, oh, that's the multiplication sign. Wrong. No, that's the cross product sign. So what we're saying here is we're taking Q and we're crossing it into P. And that gives us something known as a vector product. So that vector product I will just call V. If you take Q cross P, it's going to give us a vector V. Now, what's special about this vector V is that it's going to be perpendicular to this plane right here, because these two vectors, P and Q, are within that plane. There are 2D vectors within this plane right here, and if you take the cross product of those two vectors, the line of action for vector v is going to be right there through the plane. And it's also going to be here where the two vectors intersect. Now, in order to get the magnitude of v, there's a special formula, and we simply take the magnitude of the first vector, multiply it by the magnitude of the second vector, and then you take the sine of the angle between them. So let's look at this diagram again. This angle theta is going to be the theta value between these two vectors. So that is theta. Now, theta has a special condition. Theta is 180 degrees or less. So theta can never be 181. It can't be 272. It has to be the shorter distance, either 180 or something smaller, between these two vectors. So again, to kind of visualize that, theta is right here. We never take theta to be this angle right here, right? It's always going to be 180 degrees or smaller. So this formula right here gives us the magnitude of the resultant vector v, which is the vector product of q cross p. Now, I did say the line of action for that vector v is going to be right here. It's going to be through the plane. Now, what this formula does not do is it doesn't give us a direction. Now, in order to understand the direction of this vector v, we need to understand the right-hand rule. Now, I'm going to go over the right-hand rule in the following video, in the next video, the video right after this. But for this specific example, I'll just tell you that the direction of v, if you take q cross p, is going to be upward. So this is going to be v right here. Now, if we switched these two vectors and we said, well, what is p cross q? Then, in that case, the direction of v is actually going to be going downwards. And again, this will make sense in the following video, but I just wanted to give you what the direction would be, and then I'll explain why in the next video. Now, there's a couple other little notes that we need to be very familiar and aware of. Now, if this vector, or if these two vectors p and q were in opposite directions, so instead of these vectors right here, let's say that they're still within the same plane, and this is, p, let's say, and then this is q. Well, in this case, theta is just 180. So this theta is 180, or we could take this theta, it's both the same, right? If this is the case and we try to take the cross product, either p cross q or q cross p, then the vector product in this case is going to be 0. Well, why? Well, that's because if theta equals 180 and we try to plug this theta into this equation right here, well, sine of 180 is just 0. So it doesn't matter what the magnitudes of q and p are, this term right here is going to be 0, so this whole thing is going to be 0, and that tells us that v is 0. So that's sort of case one, where p and q are exactly in opposite directions. Now, the other case is when p and q are in the same exact direction. So let's say this was p right here, and then I'll do it in a different color, blue. Q was also along that same line. They could be the same magnitudes or different, but the point being is that in this case, theta is equal to 0. Well, if we take theta is equal to 0 degrees and we plug that into sine of theta, well, sine of 0 is also 0. So this whole term becomes 0. So the two cases that you need to watch out for is when both of these vectors, when you're trying to take the cross product, both of these vectors are in the same direction. In other words, theta is equal to 0, or they're in exact opposite directions where theta is equal to 180 degrees. Okay, awesome. So now that we sort of understand vector products and cross products, let's do a quick numerical example just so this stuff kind of solidifies and makes sense. So if I do my three-dimensional coordinate system here, this is the y-axis, this is the x-axis, and then over here is the z-axis. And I had two vectors. Let's say this is vector, I don't know, b, and B has a magnitude of 3. And there's another vector here, which I will call A, and that has a magnitude or a value of 5. And I make sure to say that both A and B are coplanar forces within the XZ plane. So we're talking about this plane right here. Now, a few more givens. This angle between them is 30 degrees. So we can say that theta is equal to 30 degrees. And the question is asking us, what is B cross A? What is this value right here? Well, we know that the vector product of B cross A is going to be equal to the magnitude of B times the magnitude of A times the sine of the angle between those two vectors. And remember, theta has to be 180 degrees or less. In this case, it is, so we take this value of theta right here, which is 30 degrees. Now, the magnitude for B is this 3, and the magnitude for A is 5. So I can write this equation as 3 times 5 times sine of 30 degrees. 3 times 5, that is simply 15, and sine of 30 is 1/2. So if I solve this out, this value is 7.5. Now, very important, this is just the magnitude of the vector product of B cross A. And we'll learn how to calculate this direction in the following video, but for those of you who are desperate to know, the direction is going to be negative. So it's going to go in the negative y-axis. It's going to go downwards. Okay, so that is it for this quick review on vector products and cross products. Hopefully that makes sense. And in the next video, we'll go over the right-hand rule and sort of understand how we can figure out the direction of a cross product.